So we have two resistors, R1 and 2, connected in parallel and forming a part of a circuit. Copy the table and fill in the missing values. Okay, so we've got R1 and R2 in the table here. We've got the total, which should be a matter of just adding the two together. So in this case they're in parallel, so it'll be using the parallel formula. Okay, so 1 over 4 plus 1 over 6, and then the inverse of that sum. To find the voltage you need the current. We've got the current through I1 and the current through I2, so we need the total current, so we just add those together, so that'll be 1.0 in this case. Since we've got the total resistance and the total current, we can then find the total voltage V equals I times R. So that solves that. It's nice and easy. The power in 1 and the power in 2, power is just current times voltage. So once you've got the current, which you do for each, and you times it by the voltage across each, which is the same as the total voltage, so whatever that value is, and you work at that voltage from V equals I times R, which we worked out before. And P2, same thing, current of that and voltage of that. So let's just go down the table. There's 4 rows, and we want to see if there's any tricky ones that we can't work out. So I'm going to change a different colour each time to make sure. So this one can be calculated the same as using the formula, the inverse formula. We can't deal with the voltage until we have the total current, which is given as 1, so we've got the total current and the total resistance, so we can find the voltage from Ohm's law, V equals I times R. If we know the resistance in each, we can then, because we now know the voltage across each, because it's the same, we can then find the current through each. Once we have the current through each and the voltage, we've got the power. That's easy. And you can start singing that song, I've got the power. I'm not going to sing it, sorry. Next one, we've got R2 and the total, so that means we can work out R1. That's good. We've got current going through I1, which is up here. That means we can work out what the voltage should be across that, because we've got the current and the resistance, means we can find the voltage. The voltage should be the same for R2, which means we can work out the current for R2. Once we have both the currents, we can find the total current, and then we've got enough information for the power once again. Okay, last one. What colour should we use for this? Red. So we don't have any of the resistance values, which could be a wee bit tricky, but we do have the fact that the current is the same in both of them. So yeah, we'll see what that. We can work out there for the total current. And we have the voltage, so we can therefore work out the total resistance. Okay, from R equals V over I, rearrangement of that Ohm's law equation. Because we know the current is the same in both of the resistors, that means the resistors will be the same, which means we can substitute in here for one value of R. It'll just be 2 over R, and we can work out what it should be. So now we've got everything, we can calculate the power, and that's wonderful. So if you got stuck on either of those 4, I suggest going through and re-watching this video to see what you have to calculate in what order.